Understanding AI techniques and being able to use them is increasingly important for engineers and scientists. However, most of the existing AI courses target computer science students, and many universities use such courses to teach engineering and general science students. However, the requirements, both in terms of scope and depth, for AI builders and AI users are different. Compare AI to a bike. The best bike makers are not the same as the best bike riders. Hence, there's a need for teaching programs focusing on AI users with engineering and science backgrounds. To fill this gap, the University of Glasgow built this series of Coursera specializations. The aim is to improve the ability and employability of engineering and general science graduates by equipping them with state-of-the-art applied AI techniques most efficiently and effectively. Engineers and scientists who are already at work and are considering continuing professional development can also benefit. So how can you gain AI knowledge effectively and efficiently? Being an AI user does not mean that you do not need to keep up to date with the newest techniques, nor does it mean that you need a superficial understanding of AI concepts and simply use software tools with AI algorithms embedded in them. Insufficient depth will result in two main issues. First, you will not be able to explain the results obtained by AI algorithms. And second, when this result is not good enough, you may find it difficult to make improvements. To call for an appropriate balance between the depth and the complexity for the targeted audience, the series of Coursera specializations emphasizes AI concepts and working principles. Where we cannot avoid teaching the involved fundamental mathematics and programming needed, our focus is to make AI techniques accessible without prohibitive mathematical and programming complexity. Therefore, our way of teaching is carefully studied. MATLAB, Python toolboxes, and interactive tools are used, some of which are prepared by the teaching team to make state-of-the-art AI techniques more accessible. Furthermore, we intentionally highlight the real-world case studies of AI techniques and teach students knowledge in practical use that is mostly not covered in AI courses for computer science students. We're confident that after studying this series of specializations, you will become an engineer or scientist who can effectively use AI techniques in a professional setting. This series includes 3 specializations. What you're looking at now is the first one, called Applied AI for Engineers and Scientists Foundations. The targeted audience of this specialization includes engineering and science students and working professionals who hope to have a general understanding of AI techniques and can use AI techniques for solving problems in real practice. With the foundation that is laid by this specialization, the second specialization, Applied AI for Engineers and Scientists, Advanced Techniques, will let you make good use of state-of-the-art AI techniques to solve most of the complex problems in your engineering and science practice. Often, this is sufficient for most engineers and scientists. For those who want to be an information engineer or data analyst, the third specialization, Applied AI for Engineers and Scientists for Data Engineering, is suitable. The programming languages that will be used for the latter 2 specializations are both Python and MATLAB, and they're hybrid programming. While for the first one, MATLAB and its interactive tools are used considering the targets. The teaching team thanks MathWorks for opening them for free to the class attendees. In this specialization, the foundation one, we carefully selected the most popular and effective AI algorithms that you will need to use. This specialization has 3 courses that consist of a total of 11 modules. The first course introduces essential MATLAB programming for AI study. The second course introduces evolutionary computation methods for intelligent optimization in engineering and science. The third course introduces machine learning methods for data analysis in engineering and science. It is suggested to finish the course in 11 weeks. The practice quizzes are not marked and the assignments are graded to obtain the certificate. You will learn widely applicable AI techniques such as genetic algorithms, particle swarm optimization, support vector machines, and artificial neural networks, and will use them to solve real-world engineering and science problems. The specialization, development, and teaching team is composed of AI experts, engineering experts, and teaching experts from the University of Glasgow. The course leader Professor Bolio is an electronic design automation expert, focusing on inventing AI-driven electronic design algorithms for more than 15 years and has had a significant impact on the AI-driven design algorithms of antennas, analog and RFICs, and filters. He has taught AI to both engineering and computer science students for years and obtained very positive feedback. He serves as a teacher designing and delivering this specialization. The whole MOOC program leader, Professor Mohammed Imran, is the Dean of Graduate Studies and the Dean of International Education at the College of Science and Engineering at the University of Glasgow. He is a distinguished research and educational leader. The specialization is a standard course for several degrees at the University of Glasgow. It has undergone sample tests at the University of Glasgow, and 90% of the students' feedback is highly satisfactory.